Irodov problem 1.67. A bar of mass m is pulled by means of a thread up an inclined plane forming an angle alpha with the horizontal as shown in the figure. The coefficient of friction is equal to k. Find the angle beta which the thread must form with the inclined plane for the tension of the thread to be minimum. What is it equal to? Let's look at the problem. First, draw the diagram. Okay. So a thread is pulling this mass up an inclined plane which forms an angle alpha with the horizontal, and the thread forms an angle beta with the inclined plane. So what is the value of beta for which the tension in the thread is minimum? We'll start with the free body diagram of the mass m. So mg is acting downwards like this. This is, let's say, the surface of the plane. Normal reaction is perpendicular to the plane. So if I extend this line, this angle is alpha, and then there is tension in the string. This angle is beta, and since the body is moving up, we can say the friction is this way, and let's say the body is moving up with acceleration a. Okay, so now we can frame the equations of motion. So along the plane, t cos beta, the component of tension along the plane, minus F, the friction force, and minus component of mg along the plane. So that would be minus mg sine alpha. This is the net force, and the body of mass m is accelerating along this direction, so F equals ma. Okay. Second thing we can say is, along the direction perpendicular to the plane, we can say is n, the normal reaction, plus the component of tension in the direction of the normal reaction is t sine beta, okay, minus mg cos alpha must be equals to 0 because there is no acceleration in the normal direction. So these are my two equations. Okay, so from this one we can say normal reaction is equal to mg cos alpha minus t sine beta. Okay, so let's say this is 1, this is 2. We can also write the force of friction is equal to k times n, where k is the coefficient of friction. That's also given. This is k between these two surfaces. So we can write this as k mg cos alpha minus t sine beta. Okay, so we have this third relation as well. Now let's substitute the value of f in this one, in equation 1. So we get t cos beta minus f, let me just expand this, minus k mg cos alpha, minus and minus will become plus k t sine beta. So f is taken care of, minus mg sine alpha is equal to ma. Now my goal is to find tension. So let's keep t cos beta plus k sine beta. Let's take all of this to the other side. MA plus KMG cos alpha plus mg sine alpha. MA plus KMG cos alpha plus mg sine alpha. So we get tension as, we could take a common, A plus kg cos alpha plus g sine alpha divided by cos beta plus k sine beta. Okay. Now question is, when will t be minimum for what value of beta? So to do that, t will be minimum when cos beta plus k sine beta, the denominator, is maximum. So if I consider, let's say, y is cos beta plus k sine beta, y is maximum when dy d beta is 0. That's the maxima minima condition. Now let's just differentiate this. So minus sine beta plus k cos beta is 0. So this becomes sine beta is equal to k cos beta, or sine by cos is tan beta is equal to k. So the value of beta for which t is minimum is tan inverse k. Okay. Now what is the value of t min? Now t min, to calculate that, in the limiting case when acceleration is just starting, so we can say in the limiting case, which is acceleration is just equal to 0, we can do this. T min becomes, let's substitute a is 0. So we have m g, let's take common, k cos alpha plus sine alpha divided by cos beta plus k sine beta. I'll just pause for a moment here. If tan beta is k, okay, so let's draw a quick triangle. Let's say this angle is beta. So if tan beta is k, it means this is k, this is 1. So this hypotenuse will be k square plus 1 root over. So therefore, our cos beta is 1 by root k square plus 1, and our sine beta, which is this, is k by root k square plus 1. Okay. So let's come back here and substitute those values. So cos beta is 1 by root k square plus 1 plus k times sine beta. So k square by root k square plus 1. So if I simplify this, if I take root over k square plus 1 in the numerator, we have k square plus 1 in the denominator. So it will effectively become k square plus 1 in the denominator, and we will have mg k cos alpha plus sine alpha in the numerator. So this is my minimum value of tension. Okay, so that's our solution.